Okay, so good day and welcome to this lecture about types of equilibria. So, in your second term here in the laboratory, so we will discuss three types of equilibria, which is acid-base, precipitation, and complexometric. So, magkakaiba yung equilibria and then we will discuss it in detail in the following week. So, the following week, I will upload materials about acid-base equilibria. So the week after is the precipitation, and then the week after that, we will already switch with Sir Hill. So he will be discussing first thing to you about complexometric equilibria. So, ano ba yung pinagkaiba ng tatlong equilibria na to? So, sa acid-base equilibria, so syempre, as its name suggests, you have acid and base species. Ang special dito is that they are considered as equilibrium of equilibrium uh, of dissociating dissociating species. Species. Ayan. So, sa acid-base equilibria, you have the equilibrium of dissociating species. So, ano bang ibig sabihin nito? Sa sa acid-base equilibria kasi usually we are thinking about we are thinking about weak acids and weak bases. Kasi kapag meron kang strong acids at strong bases, so meron kang complete dissociation. So for example, your hydrochloric acid, so you have complete dissociation into H plus and chloride ions. But unlike strong acids, so weak acids like the example here, acetic acid and then the weak base ammonia has an equilibrium between its dissociating species and the weak acid or weak base itself. So in this case, so let's take the first example. Acetic acid dissociates into acetate ion plus hydronium ion. So now, in this scenario, you have a constant which establishes the equilibrium between these species. So you have here Ka. Ka stands for acid dissociation constant. So itong Ka na to, so pwede siya maging Ka1, Ka2, Ka3, depende sa depende sa dami ng hydrogen na pwedeng mag-dissociate. So I will expound on this on the following week with the lectures on acids and bases. And then, yung Kb naman, so Kb stands for base dissociation constant. So, ganun din yung kanyang rationale. So, same lang siya sa acid dissociation constant. Pero, itong Kb ay related naman siya sa bases. So, yung Ka, so usually this is used for uh, weak acids or the calculation of your pH or the power of hydrogen. So yung Kb naman ay ginagamit sa calculation of pOH. So paano ba ang pag-calculate ng Ka at Kb? So kung makikita natin dito, so Ka is equal to the concentration of acetate ion times the concentration of hydronium ion all over the concentration of acetic acid. So kung mapapansin natin dito, so yung nasa right side ng equation, so sila yung nasa numerator. And then, yung nasa left side, sila yung nasa denominator. So, kailangan nyo itong tandaan kasi magkakaroon mamaya ng difference pagdating sa formation constants naman. So sa KB, same lang din. So yung nasa right side, nasa numerator, and then yung nasa left side ay nasa denominator. So kung papansin nyo, dito sa dissociation, so wala kang wala kang coefficients kasi it's just the removal or acceptance of the of a proton kapag ka nagkakaroon ka ng dissociation or kapag ka naman sa base, pagka naman nag-accept siya ng proton, so protonation. So, if you will remember in your previous chemistry subjects, you have your Bronsted-Lowry, your Lewis, and then your Arrhenius definition of acids and bases. So, may apply nyo rin siya dito. So, dito, yung NH3 is na-protonate siya para mag-form ng NH4+, and then yung nag-protonate na water, so nag-lose siya ng hydrogen, kaya naging OH. So, for now, ito lang muna yung dapat mong malaman para sa acid-base equilibria. So, next is the precipitation equilibria. So, itong precipitation equilibria is an example of heterogeneous equilibria. So, heterogeneous equilibria, ibig sabihin, you have two different phases sa reactant at sa product. So, dito, ang example natin is silver ion reacts with iodide ion, so both in aqueous phase, and then it produces your silver iodide, which is a solid. So dito, sa precipitation equilibria, so based dun sa previous lecture, so nakita nyo naman na dito sa previous upload, so sinabi naman dun na kapag yung solids, yung pure liquids, so hindi sila sinasama sa expression ng equilibrium. So in here, we will introduce another type of equilibrium constant, which is K sub Sp. So this stands for solubility product constant, which is equal to the concentration of silver times the concentration of iodide ion. So kung papansin natin, wala yung AgI dun sa equation kasi solid siya. So dito sa precipitation equilibria, so ito na yung isa sa mga type ng reaction na magkakaroon na ng effect yung ratios, yung mole ratios ng iyong participating ions. So kapag nagpunta tayo dito, so probably next week, so magkakaroon na dyan ng mga, halimbawa meron kang 2 dito, so magkakaroon na din ng exponent dito. So yun yung primary difference niya sa acid-base equilibria. So meron ka ng mga exponents, tsaka wala yung solid species. So then, for the last one, so we have complexometric equilibria. So ito yung formation ng complexes. So complexes, so kapag, I don't know if this was already discussed with you, but complexes are definitely some compounds which have bright colors or colors in general. So ito yung meron kang central metal ion, and then naka-complex siya with ligands. So in this case, meron tayong tetraaquo copper 2 plus. So plus ammonia. So nagkaroon ka ng triaquo amine copper 2 plus. I don't know if the name is correct, but in this complexation reaction, so meron pa ding equilibrium constant, which is called your formation constant. So during these complexation reactions, so ang tawag naman, ang equilibrium naman dito is equilibrium of associating species. So, kung yung acid-base equilibria ay nag-i-involve ng dissociation, ito namang complexation ay nag-involve ng association of your ions, your ionic species. So, in this case, ang Kf mo, so formation constant is equal to the concentration of your formed complex over the concentration uh, of your ions that reacted to form your uh, complex. So, ano ba ang significance nito? So, nag-differ siya dito sa Ka, Kb sa acid-base equilibria in that the product on your right side now is in the numerator. And then, the reactants on the left side is on the denominator. So, nakita niyo yung difference. So, dito, yung nasa right side, nasa denominator, yung nasa right side, nasa numerator. So, ito lang muna yung i-discuss ko. So, let's have a quick recap. So, meron pang tatlong equilibria, acid-base, precipitation, at complexometric. So, yung acid-base is equilibrium of dissociating species. Precipitation is heterogeneous equilibria. And then your complexometric equilibria is equilibrium of associating species. So, meron silang tatlong types ng equilibrium constant na nagre-relate sa mga concentration ng participating ions. So, sa acid-base equilibria, meron kang acid and base dissociation constants. So, Ka or Ka tsaka Kb. Sa precipitation equilibria, meron kang solubility product constant, K sub Sp. And then, sa complexometric equilibria, meron kang formation constant, Kf. So, I guess this ends this lecture. So, we will first delve into acid-base equilibria next lecture. Thank you for listening.